So here we have a circuit that's not a complete circuit, it's part of a larger circuit. So we're just looking at these two particular nodes to try to figure out what are the currents passing through these two resistors. So if we start with the one thing we know is that we have 6 volts at node 1. So we know that this potential is 6 volts compared to Earth. So we can then apply Kirchhoff's current law to node 1. So Kirchhoff's current law at node 1. So we've got 10 milliamps. We know that's going in that way. So the summation of the currents entering the node need to be 0. So if we say the current in this branch is in that direction and the current in this branch is in this direction, so if we call this I2, and I'm talking about the one going through the source, this current here we can find, if I call this I1 is simply V1 divided by 2K. So it's 6 over 2K, so 3 milliamps. So we know we have 3 milliamps going this way, and Kirchhoff's current law, so you've got 10 minus 3 minus I2 equals 0. So I2 is 7 milliamps. So that sort of makes sense. We've got 10 milliamps going in, we've got 3 milliamps going this way, therefore 7 milliamps going that way. Now, we notice we have a 10 volt EMF here, so the voltage, the potential at this point is 10 volts higher than the 6 volt there. So we can say that the potential at 2 is 6 plus 10 equals 16 volt. And if we know the potential here, we can find the current that's passing through this resistance here. So I can say, if we call this current, I don't know, I3, we can say I3 is V2 over 8K, which is 16 over 8K, which is 2 milliamps. So now we know that we've got 2 milliamps going this way. So if we apply Kirchhoff's current law at node 2, so let's do that there. We know we have 7 milliamps going this way. So 7 minus I3 minus, let's call this I4, minus I4 equals 0. So 7 minus 2 minus I4 equals 0. So I4 equals 5 milliamps. So we found the current that would pass through this resistor if it were part of a larger network. We found the current that would pass through this resistor. And as a bonus, we found the current that would pass through this resistor. So that's how you would answer a question like this.